Language-specific formats. Many programming language come with built-in support for encoding in-memory objects into byte sequence. For example, Java has Java.io serializable, Ruby has Marshall, Python has Pickle, and so on. Many third-party libraries also exist, such as KRYO for Java. These encoding libraries are very convenient because they allow in-memory objects to be saved and restored with minimal additional code. So that in-memory objects, the one we store in memory, can easily be restored using these libraries. However, they also have a number of deep problems. The encoding is often tied to a particular programming language, and reading data in another language is very difficult. If you store or transmit data in such encoding, you are committing yourself to your programming language for potentially a very long time and precluding integrating your systems with those of other organizations which may use different languages. In order to restore data in the same object types, the decoding process needs to be able to instantiate arbitrary classes. So to restore data in that same object type that you create in memory, the decoding process needs to be able to instantiate arbitrary classes. This is frequently a source of security problems. If an attacker can get your application to decode an arbitrary byte sequence, they can instantiate arbitrary classes. So if they can decode like any byte on your actual database or byte sequence, they can also instantiate arbitrary classes on your in-memory, which in turn often allows them to do terrible things such as remotely executing arbitrary code. So what does this mean in details? The sentence is stated in plain language. If your system blindly turns bytes into objects, attackers can trick into creating objects you never intended, and those objects can execute code. This is about deserialization. Core idea, one sentence. Decoding bytes into behavior is dangerous unless tightly controlled. Why this is a big deal, the deep reason. Data should be data, code should be code. If you blur that line, security collapse. Map this to everything we discuss. First, CPU analogy. This is the cleanest mapping. What CPUs never do. A CPU fetches bytes, decodes them into instructions, execute them, but it never treats random data as instructions. Instructions come from code pages, data comes from data pages. This is enforced by NX-bit, no execute, page tables, privilege rings, instruction decoding rules. If CPU is allowed, any bytes in memory can become instructions. Malware would win instantly. The serialization bug equal removing NX bit in software. If your app deserialize argument bytes to new sum class without strict control, bytes become objects, objects become have methods, methods run code. That is software level arbitrary execution. Second, SQL and column store connection. Why SQL feels boring and strict? SQL engines do not deserialize rows into arbitrary objects. Data types are primitive. Int, text, timestamp, no new class from disk. Even UDFs are sandbox, registered explicitly, not user controlled. This is intentional. SQL refuses to mix data and behavior. That's why column stores are safe, bitmaps are safe, RLE is safe, aggregation is safe, no data can suddenly become code. Third, Firestore Supabase object storage. Why object storage is safe by default? Supabase storage stores bytes, return URLs, never instantiate objects, never executes contents. This is why you store file underscore URLs text You don't store file object. If you tried to upload a serialized JS object, download it json.parse plus new class, you've now crossed the line. Fourth, Redux connection. This is important. Why reducers must be pure? Redux state is a plain data, JSON serializable, no classes, no methods, no functions. Why? Because Redux replaces actions, time travel, serialized state, hydrate states. If Redux allowed state.user equal new.user, then rehydration could instantiate arbitrary classes, time travel could execute code, DevTools becomes an attack surface. So if you time travel, like changing the previous version, those could execute code that cause the accidental bug in your global state. DevTools becomes an attack surface. Redux deliberately prevent this. This is the same rule. Why JSON is safer than class-based serialization? Safe. So you have ID colon 123, then next line content colon hello. Dangerous, object input stream that read object or unserialized or eval argument serialized data. Because JSON to data, object serialization to behavior resurrection. Real-world attacks this refers to. This paragraph is referencing things like Java deserialization RCE, PHP unserialized RCE, Python Pickle RCE, Ruby Marshall.load exploits. All of them decode bytes, instantiate arbitrary classes, trigger constructors or magic methods, execute attacker control code. Why modern systems avoid object deserialization? Databases store rows, not objects. API use JSON, not PCAS. Front-end state is POJOs, not class instances. Storage engine store primitives, not behavior. CPUs separate code and data physically. 8. Connect this back to your comment CRUD plus file upload. Why your design is correct? You did file underscore URL text, not file object, not serialized class. Files stored in object storage serve as bytes rendered by browser sandbox. Your DB knows nothing about file contents, just stores a pointer. This is perfect separation. Why this fits your mental block? You've been trying to unify CPU pipelines, SQL engines, Redux purity, storage engines, security. This paragraph is the security version of the same rule. Never let representation imply behavior unless you fully control it. Number 10, one sentence that ties everything together. Column stores, Redux, SQL, CPUs, and secure storage all succeed because they treat data as inert, never executable, and strictly control when the behavior is allowed. That's unifying principle you were circling. In the context of programming and system design, PCAS refers to a Python-specific way of freezing an object so it can be saved to a file or sent over a network. Here's a breakdown of why that term is used in your list and why your modern systems are moving away from it. What is pickling? In Python, pickling is the process of serialization. It takes a complex object like a list of user profiles, a machine learning model, or a database connection object and converts it into a byte stream. Unpickling is the reverse process, turning those bytes back into a live object in memory. Why the list says use JSON, not PCAS? The list you provided is highlighting a shift toward interoperability and security. Here's how they compare. Feature readability, JSON human readable text, PCAS, Python, binary, looks like gibberish to humans. Feature language, JSON universal, works with Java, JS, C++, etc. PCAS, Python, language specific, mostly works only with Python. Feature security, JSON generally safe, just data, PCAS, Python. Dangerous, can execute malicious code during unpickling. Feature flexibility, JSON great for simple data, list, dicks. PCAS, Python great for complex Python specific objects. The modern system problem. The reason modern systems avoid object deserialization like PCAS or Java serialization boils down to two main issues. First, the gadget chain attack. When a system unpickles data, it doesn't just read values, it often reconstructs the object's behavior. An attacker can craft a malicious pickle that, when opened, tells the computer to delete files or open a backdoor. Second, the walled garden. If your database stores pickles, only a Python application can read that data. If you ever want to rewrite your app in a different language like Go or Rust, your data becomes unreadable dark data. In short, using JSON ensures that your data is just information, whereas using pickles makes your data executable code, which is a massive security risk in modern API design.